Dark energy, the mysterious force driving the accelerated expansion of our universe, represents the most significant energy component of the cosmos, yet its origin and precise value remain profoundly baffling. Current cosmological models accommodate its existence through the cosmological constant, sometimes called lambda, or dynamic scalar fields, but they largely lack a fundamental, first principles derivation that explains why it exists and what its exact magnitude should be. This missing piece is a critical challenge in modern physics, often referred to as the cosmological constant problem, the staggering discrepancy between theoretical predictions from quantum field theory and observed values. The 11-dimensional model of the universe offers a revolutionary framework that proposes to resolve this enigma. By defining a universe built upon a hierarchy of 11 interconnected dimensions, each with inherent properties and interactions, this model posits that dark energy is not an arbitrary input or an emergent property of four-dimensional spacetime, but a direct, fundamental consequence of the model's deepest first principles, particularly the intrinsic nature of the 10th dimension. This essay will outline the conceptual path towards precisely deriving the nature and ultimately the value of dark energy from these foundational principles. At the core of the 11-dimensional model lies a systematic unfolding of reality through a hierarchy of dimensions, each introducing new physical properties and interactions. The 0 dimension represents pure potentiality, a dimensionless point. From this, the familiar first, second, and third dimensions of space emerge, allowing for length, area, and volume, and the formation of matter. The 4th dimension introduces rotation, weaving space and time into the fabric of spacetime. Beyond our observable 4-dimensional reality, the model postulates higher dimensions, the 5th through the 9th, that govern increasingly complex cosmic dynamics, from orbital motions to galactic structures. Crucially, the 10th dimension and the 11th dimension are the primary drivers of the universe's large-scale behavior and the key to understanding dark energy. The 10th dimension embodies an inherent deterministic expansive drive, representing the universe's fundamental tendency to push outward and grow. Conversely, the 11th dimension represents a pervasive, contractive, and quantum web intrinsically linked to phenomena like quantum entanglement and the subtle pull of gravity. The fundamental interaction and dynamic tension between this expansive 10th dimension and this contractive 11th dimension give rise to the universal wave, the very fabric of reality. All observed particles, forces, and spacetime itself are considered expressions or knots within this universal wave, determined by the precise resonance and interplay of these dimensional forces. The first step in deriving dark energy is to establish its fundamental nature within the 11-dimensional model. From its first principles, dark energy is not a particle or a field that exists within spacetime. Rather, it is the inherent, pervasive, expansive property of spacetime itself, directly attributable to the fundamental nature of the 10th dimension. The first principle here is the definitional characteristic of the 10th dimension. It is axiomatically endowed with an inherent outward pressure or expansive tendency. This isn't a force applied to space, but rather the intrinsic property of the dimension that generates space and drives its expansion. Just as mass inherently warps spacetime in general relativity, the 10th dimension inherently expands spacetime. The expansive drive of the 10th dimension is not localized, but is a fundamental component of the universal wave that constitutes all reality. Because the universal wave is ubiquitous, the expansive property imparted by the 10th dimension is also ubiquitous. This explains dark energy's pervasive nature. It's everywhere because the universal wave, driven by the 10th dimension, is everywhere. The inherent pushing nature of the 10th dimension directly translates to an anti-gravitational effect. While the 11th dimension's contractive quality contributes to gravitational effects and the gathering of matter, including dark matter, the dominant expansive drive of the 10th dimension acts as a cosmic repulsion, accelerating the expansion of space itself. This conceptual derivation explains why dark energy behaves like a cosmological constant, appearing as an inherent energy density of the vacuum. Therefore, the nature of dark energy is fundamentally understood as the energetic manifestation of the 10th dimension's inherent expansive property, seamlessly woven into the universal wave that forms spacetime. Moving from the conceptual nature to a precise numerical value for dark energy, like its energy density of approximately 6.8 times 10 to the minus 27th kilograms per cubic meter, is the ultimate and most challenging step. This requires a rigorous mathematical framework that can quantitatively link the abstract properties of higher dimensions to observable cosmological parameters. The key challenges and necessary theoretical developments include a complete field theory of 11 dimensions. Just as general relativity provides a field theory for 4-dimensional spacetime, a comprehensive 11-dimensional model would require a novel field theory that describes the dynamics and interactions of all 11 dimensions. This theory would need to generalize the concept of a metric tensor, that's G mu nu, to an 11-dimensional manifold, and define how energy momentum is distributed across these dimensions. Quantifying dimensional influence is another big step. The inherent expansive drive of the 10th dimension must be mathematically formalized as a term within this 11-dimensional field theory. This might involve introducing a dimensional tension or pressure term, basically a fundamental constant or field directly related to the 10th dimension's expansive tendency, which would act as a source term in a generalized set of field equations. There's also the challenge of resonance and interference dynamics, modeling the precise way the universal wave, generated by the interaction between the 10th and 11th dimensions, contributes energy density to the observable 4 dimensions. This could involve complex, multi-dimensional interference patterns where the net push from the 10th dimension contributes to the vacuum energy. So let's talk about dimensional reduction and emergence. A crucial step here would be to figure out how the full 11-dimensional dynamics actually reduce or project onto the 4-dimensional spacetime that we observe. The mathematical process of this dimensional reduction would need to, naturally yield a cosmological constant term, one that's directly traceable to the expansive force of the 10th dimension. This could involve specific compactification schemes or maybe emergent properties that arise from the higher dimensional interactions. And then, relating this to standard cosmological equations, the derived term for dark energy must naturally fit into extended versions of Einstein's field equations like this: R mu nu minus 1/2 R g mu nu plus lambda g mu nu equals 8 pi g over c to the 4th t mu nu. The challenge really is to show how lambda, or, an equivalent dynamic term, precisely emerges from the first principles of the 10th dimension's activity within the 11-dimensional model. This would require relating the fundamental dimensional pressure to the energy momentum tensor's vacuum component. A roadmap for such a derivation would involve a few key steps. First, there's the axiomatic definition of dimensional properties. Rigorously define the inherent properties, like expansive potential and contractive potential, for each of the higher dimensions, especially the 10th and 11th, and possibly assign them fundamental dimensional constants. Next, you'd want to develop a robust mathematical framework, maybe something like generalized differential geometry, a new type of field theory, or even a multi-dimensional string-like theory, to describe how these dimensions interact to form the universal wave. And finally, you'd need to actually derive the universal wave equation, an equation that describes the dynamics of the universal wave as a result of the tension between the 10th and 11th dimensions. So let's dive in. The mechanism here is all about how the energy and momentum content of this universal wave actually projects onto our observable 4-dimensional space-time. This projection gives rise to terms that correspond to matter, radiation, and most importantly, dark energy. Now, from these projected terms, we can mathematically derive the value of the cosmological constant, or maybe even a dynamic dark energy parameter. That means we're looking at computing the intrinsic energy density that comes from the 10th dimension's expansive influence. This could involve integrating its pressure over the very fabric of reality, or perhaps analyzing its resonant frequencies within the universal wave itself. And honestly, this is the point where we need to tackle that observed discrepancy of 1 part in 10 to the power of negative 122. If the 11-dimensional model could precisely derive the nature and value of dark energy from its first principles, the implications would be absolutely profound. First up, it would resolve the cosmological constant problem, offering a natural and elegant explanation for the existence and magnitude of dark energy, and finally removing the most significant fine-tuning problem in physics. It would also mark a monumental step towards unifying quantum mechanics, general relativity, and cosmology within a single, coherent framework. And, if the model is truly successful, it might even predict other fundamental constants or cosmological parameters, opening up entirely new avenues for experimental verification. Honestly, this would fundamentally reshape our understanding of the vacuum spacetime and the very origin of the universe itself. It would reveal a far richer, multidimensional reality than we'd ever previously conceived. The quest to derive dark energy from the first principles of the 11-dimensional model really represents the ultimate test of its explanatory power. It demands not only conceptual elegance, but also a rigorous mathematical formulation that can bridge the vast chasm between theoretical dimensions and observable cosmic phenomena. While the path is, quite arduous and requires some truly novel theoretical developments, a successful derivation wouldn't just unlock the secrets of dark energy. It would also provide an unprecedented, unified cosmic map, bringing us closer to a complete understanding of existence. The real ambition here is to show that dark energy isn't just some arbitrary input, but rather an inevitable consequence of the universe's inherent dimensional architecture. If you enjoyed this journey into the mysteries of the universe, don't forget to like, subscribe, and definitely share this video with fellow explorers. Your support helps us unlock even more cosmic secrets.